Hi everyone, in this video I would like to talk about how to use perpendicular diagonals in a quadrilateral, especially for convex quadrilateral. Alright, so here we go. This is going to be, I think I need to give you a certain picture. It doesn't have to be necessarily some special quadrilateral, but if I have all those setups, well, we get A and we get B and we get C and we get D, and it just looks like some kind of a kite, but kind of a tilted kite, especially when the diagonals are perpendicular. I think in competition math, you guys can actually use the fact that b squared minus a squared is in fact equal to c squared minus d squared. Now, I think I need to show you why it works. So in order to do so, I got to label it x and y, and I'm going to label this x and y and p and q. All right, so check this out. We understood from the very first triangle, especially when p becomes the height, I can actually say that b squared equals p squared plus y squared. But at the same time, you can say that a squared equals p squared plus x squared. So if you subtract these two expressions, we get b squared minus a squared equals y squared minus x squared. Now, what is y squared minus x squared on the bottom triangle? So you can actually see these two set of triangles such that we have x plus y and c and d, the triangle such that q becomes the height. Well, we understood that we have those two right triangles. Now, using all those right triangles, in fact, I can actually rewrite that c squared equals y squared plus q squared. And at the same time, I can also write it down as d squared equals x squared plus q squared. So if you subtract it out, you get c squared minus d squared equals y squared minus x squared. So in fact, y squared minus x squared and y squared minus x squared, we have the common terms by transitivity. We get b squared minus a squared equals c squared minus d squared. And this is how the identity of, identity comes out. And of course, if I somehow rearrange these terms, we kind of get some interesting fact saying that a squared plus c squared equals b squared plus d squared. So the opposite sides, the sum of the squares of the opposite sides are invariant. In other words, I can rewrite those following format as c squared plus a squared or a squared plus c squared. However things that you write, it's just going to be same thing as b squared plus d squared, and that shall be it.